So today we're going to be taking a look at another trig identity here and just kind of go through a few pointers on what is the best way to tackle them from the beginning, right? So some of the things that we always want to make sure that we're doing is breaking these things up into their sine and cosine equivalents. So we don't want to try and use tan, cotan, secant, cosecant. These make it more difficult for us. The other thing we want to do is we don't want to have it written like this as two separate fractions, let's call it. We want to write everything as a single term if we can, because that makes it a heck of a lot easier for us to start simplifying both of these down. So let's go ahead and let's begin doing that. So if we take a look at this first one here, let's just check my color actually, let's not use black. All right, so what we want to do is we want to take that one and we're going to separate it. Now, if it's 1 over tangent, that's the same as cotangent, so we're going to start with that. Then we're going to take this one and split it apart. Well, we know that tangent is really sine over cosine, so we'll do that. And we're going to do it to the other side, but as we do the other side, we're also going to put that line down the middle, because of course the whole point of this is we want the left side to be equal to the right side. That's the point of like a trig identity, right? So then we're going to take this other one. Now, because we've got both things that are fractions, I know that a lot of us get kind of freaked out when we see a bunch of fractions. So instead, I'm going to separate that and say that it's secant squared theta divided by tangent of theta. Okay, that makes it so that the fractions don't come off quite so terrifying at the beginning. Now, you could still do it that way and there's nothing wrong with it. It'll still be correct. Now we can, of course, continue to break these things down. So let's just work on the left side here for a little bit. So cotangent is the opposite of tangent, or the inverse. So it's going to be flipped, right? Cosine over sine. And then, of course, we're adding it to sine of theta over cosine theta. Now, as we said, we wanted to try and get that as a single fraction. So we're going to go ahead and do that here. And so we need a common denominator, which basically just means we're going to multiply this one by cosine over cosine. And we're going to multiply this one over here by sine over sine, because then we get that common denominator. So I'll have cos theta sine theta as my common denominator. And on the top, we just need to simplify it. So cosine times cosine is going to be cosine squared. And then over here, we've got sine times sine. Well, that's going to be, of course, sine squared theta. Now, a lot of the time I would stop there because at least I've got it as a single term, and then start working on the other side, see if I can figure out where they're maybe going to equal out. But if you see something this obvious, you should probably simplify it. Cos squared plus sine squared, that's one of our identities that we've talked about before. And so we want to use that immediately and just say, you know what, that's the same thing as 1. So this is really 1 over cosine theta, sine theta. At that point, there's not much more we can do. So most likely, whatever else we do is going to have to go on the other side. So let's flip over to the other side, okay? And let's break them apart into sine and cosine as well. So secant is really 1 over cosine. So this is 1 over cosine squared of theta. And then tangent, we already know, is really sine over cosine, right? These are some basic ones that we should just know by heart by now. And then what we want to do is figure out, like, well, how do we divide fractions? Well, we keep change flip, meaning the first one stays the same, 1 over cos squared theta. The second fraction, or then we multiply, and we're going to flip that second one. So it's going to become cosine theta over sine theta. At that point, we can, of course, see that we've got a little bit of cancellation. So let's change our color for that to show it. So the squared would cancel out with one of those cosines. And so then we would be left with 1 over the cosine of theta times the sine of theta. At that point, we can see that these two things are equal, and so there's nothing else we need to do. The only thing that you may want to do is kind of just reiterate it and say that the left side is equal to the right side. I even like to put a check mark, but you're just denoting, hey, these two things are indeed equal. Now, the other part of this that we often are asked for in any sort of rational expression, whether it be trigonometric or not, is that we want to look at, like, what are the non-permissible values? In other words, when can we not divide by 0? Or if we have a root, when can it not be negative? Okay? Now, the tricky thing about this is this has to be true at all times, meaning that if we divide a fraction and therefore we flip it, both the numerator and denominator, at some point, we're in the denominator. And so we have to be careful of that. So let's go up here and look at this for a second. So the obvious ones here, of course, are that we have tangents on the bottom. And so really what we're going to do here is just sort of highlight anytime something ended up on the bottom. And let's maybe do it in orange to kind of show, hey, there's a caution here. We can't do this. So here, something's on the bottom. Here's something on the bottom. But here, the other thing is on the bottom, right? And if we look on the left side here, of course, with cotangent, we've got sine on the bottom. And then with tangent, we have cosine on the bottom. So basically, if we look at this, what it means is that sine and cosine are never allowed to be zero, right? Because if they were zero, we would be dividing by zero. Now, technically, we could argue, oh, actually, it's also like cosine squared couldn't be zero. But of course, that's the same as saying that cosine can't be zero, right? If I set up cos squared cannot equal zero and we square root it, square root of zero is still zero. So really what we need to do is just make sure that both cosine and sine are never zero. Now, again, we could look at this a little bit more intricately and say, well, there's actually a tangent on the bottom, and tangent would be zero when when sine is zero. Well, that already takes care of it because we've already determined, hey, look, there's sine and cosine that are on the bottom. Okay, so then what we can do is we can go and actually analyze those. So what needs to be true is that cosine of theta cannot equal zero, and sine of theta cannot equal zero either. Neither of these things are allowed to be zero. So then what we do is we just kind of look at them. And this is where the unit circle is, of course, going to come into play here. So for us, for cosine, this is, of course, going to happen if we think about like where it's going on the unit circle, right? We know that over here it's 1, and we know that over here it's going to be -1. And so our zeros, of course, are going to be at these two here. So this is where cosine will be 0. Okay? So that means that cosine of theta will not be allowed to equal, and this here is going to be pi over 2, 90 degrees, but let's try to use radians, or at 3 pi over 2. Now, at that point, you can kind of see that those are the same thing, and so we can write a generic statement just by simply saying that theta cannot equal, sorry, I shouldn't say that cosine of theta can't equal that. Cosine of theta can't equal 0. What we're actually looking at is just that theta cannot equal these things. My apologies. Okay, well, there we go. So theta, in this case, cannot equal pi over 2 plus or minus pi n, where n is an element of the integers, okay? And so we can say where n is an element of the integers, meaning if we add pi or subtract pi any number of times, we will always end up hitting on one of these 2 points where cosine of theta will be 0. Now we're going to do the same kind of thing for sine, except that sine is the exact opposite, right? Where it's going to be 1 up here, -1 over there, and then it's 0 on the 2 ends of the x-axis. So in this case, this means that theta will not be allowed to equal 0, pi, 2 pi, etc. Which again, we can simply write that as a single statement and say that theta cannot equal 0 plus or minus pi n, where n is an element of the integers. Okay? Now, you might look at this and say, well, great, can't we like put these together? And sometimes you can, sometimes you can't. In this particular case, we will be able to, because if we look, really what's happening here is we cannot be any of our kind of cardinal directions, right? So straight up, straight down, straight left, or straight right. We can't do any of those. So if we wanted to put them all together, okay, we can do that. However, you do not have to. You can always leave it in these two different, like these two statements together are your answers. Okay, but if we want to be, more efficient or whatnot, then we can. And so what we're going to do is we look here, it's theta is not allowed to be 0 or pi over 2 or pi or 3 pi over 2. And so really what's happening here is we're adding or subtracting pi over 2 plus or minus pi over 2n, where n is an element of the integers. And this is basically combining both of those statements to say that we can't be any of those cardinal directions, right? If we end up, oh, look at that. What's that? I wrote that twice. My bad. We shouldn't have the 2 pi over n's there. It should just be one of them. I don't know why I wrote pi over 2 twice there. So here, let's clean that up for you. It should just be 0 plus or minus pi over 2n, where n is an element of the interest. And so this gives us everything that we would need for this question, because there's no other way, there's no other parts of this equation where we're going to get something on the bottom. There's no roots, so we don't have to worry about something, being negative in a square root. So in that case, we've answered everything that we need to for this one. Guys, I hope that was helpful. If it was, make sure you guys go ahead and hit the like, subscribe button. If you're ever looking for any one-on-one time, obviously we do that as well, so you can reach out to our company.